Hello everybody and welcome to today's webinar. Thank you so much for joining us today. As you know, today's session is on 12C adaptive optimization and the main presenter today is Kerry Osbourne. So as I've just mentioned, today's presenter is Kerry Osbourne. I'm sure a lot of you have followed Kerry either at conferences or maybe you follow his blog. Or you follow him on Twitter. If not, please do follow him at Kerry Oracle Guy. If you don't know, Kerry's an Oracle ACE Director, a member of the Oak Table, and he's the founder of IncaTech. As always, I'm James Mercer. You can follow me on Twitter at jmertz. I'm part of the Oracle Tools team at Redgate, and I'm the creator of all things oracle.com. Today's webinar is brought to you by Redgate Software and IncaTech. So just a couple of things before we get going. Everybody will be on mute for the duration of the event. If at any time you can't hear us, please do first check your own audio settings. Make sure that your speakers are connected. Make sure that the GoToWebinar console is working okay. Sometimes the sound can go. As you imagine, quite a lot of people logged in. Obviously, Kerry and myself, we're in different parts of the world. Do let us know if the sound starts going bad. Either do that through the chat box or through the questions panel in your GoToWebinar console. There will be a Q&A session at the end of the webinar, but please do type questions in advance, particularly as Kerry covers particular topics and points that you want a little bit more explanation on. We won't actually answer these questions until the end, where we'll go through a full Q&A. As always, this session is being recorded, and a recording of the webinar will be put up online as soon as I can, along with the slides as well. So before we get started with the main presentation, we can talk a little bit about Redgate and about IncaTech. Hopefully those of you that have come to these sessions regularly, I'm always so pleased to see so many familiar faces, or familiar names rather, in the console. It's fantastic. Hopefully you've had a chance to check out Redgate. For those of you who have never heard of Redgate, we're a technology company. Over 600,000 professionals worldwide use our software, including 93% of the Fortune 100 companies. Some logos up on the screen here. These are the types of companies that are using Redgate's products every day to solve complex problems. Our philosophy is to design highly usable, reliable tools that solve problems commonly faced by developers and DBAs. So we're primarily a database company, but we do produce tooling as well for .NET applications. On the Oracle side of our business, we focus on Oracle database delivery, and we've got a number of tools here which fit into the deployment suite for Oracle. The core focus of these tools is to make it easy for you to deploy changes from development through testing and then into your production servers. So as you can imagine, a key part of that is source controlling your code. So we've got a tool that helps you source control code easily, your database code. And then we have other products that enable you to compare and deploy schema and table data through environments. I've got a little quote up here on the screen that you can read by somebody that's used source control for Oracle, Lewis Cunningham, who's a database architect and an Oracle ACE Director. You can read more quotes and reviews and find out about our Oracle tools at redgate.com/Oracle. So please do take note of that URL and check this out after the webinar. Okay, I'm going to hand over to Kerry briefly to tell you a little bit more about IncaTech.
Hello, everybody. I don't have a whole lot to say about IncaTech other than, we're an Oracle-focused consulting company, so we do a lot of work with Exadata and are very interested in big data these days. But so we're just a collection of a bunch of Oracle guys. That's it.
Thanks, Kerry. Okay, so without further ado, I'm now going to hand over to Kerry to take you through the main presentation, which is 12C adaptive optimization. Please do bear with us in case there's a little bit of a delay as I hand things over.
Okay, does that look all right, James?
It looks great, Kerry. I shall leave everything with you now.
All right. Well, welcome everybody. I appreciate you dialing in here and listening to me. I'm going to talk a little bit about adaptive optimization in 12C, which is one of the newest and most interesting features of 12C, at least from my perspective. So we'll just get started. Real quickly, a little bit about me. Never worked for Oracle. Been doing Oracle since '82, so a long time. I've been working with Exadata for quite a while, and as I said, I work for IncaTech. That's where you can find us on the web. IncaTech has a bunch of Exadatas in our lab. We got really excited about Exadata when they first came out, and so we bought some and took them apart with a screwdriver and put them back together so we could figure out how those things worked. We also have some other engineered systems in our lab, BDA being one of them that we're pretty excited about Oracle's foray into the big data world. So I've worked on a couple of books, an Exadata book and a Pro Oracle SQL book with Karen Morton. As I said, I like big data stuff, and I'm also a fanboy, so keep in mind if I talk about Exadata, you know, it's you got to take everything with a grain of salt with me on that topic. As James said, I'm in a couple of clubs, and so there's a picture of our BDA. The best feature of it is the beer shelf, so I like to keep that picture around to remind myself what's good about it. All right, so just to get started, what I did last week and what I do most weeks is I play a game called WhackaMole. I don't know if everybody has seen that video game, but basically there's little things that pop up and you have to whack them as fast as you can. So in the performance world, that seems to be what we do a lot of. When problems pop up, we spend a lot of time going around and whacking the problems that pop up. And so that's one of the things about this new adaptive optimization, that hopefully we'll have less of that whack-a-mole kind of game to be played. And so that's what I'm going to talk about. So what's the point? Sometimes the optimizer makes mistakes. You guys are all aware of this. Sometimes it's you know, a plan change. That's usually what the problem is, and many times it's caused by a misestimate, you know, of cardinality somewhere. So it's often pretty easy to spot those mistakes. And so in 11, we had some pretty good techniques for spotting those things and fixing them later. But the idea with 12C with adaptive optimization is to try to fix them on the fly when they happen, so that we don't have bad performance that we have to fix later. But let's catch them on the fly. So how does it mess up? Well, generally it's cardinality is the main, you know, one of the main issues. So misunderestimate, as Bush would call it. It's pretty easy to recognize, you know, if you do a gather plan statistics or you look at a SQL monitor report, you're going to see that the estimated rows that the optimizer thought he was going to get is not equal to the actual rows that he did get. So, you know, if it's so easy to recognize it, then, you know, we ought to be able to programmatically fix it. And there's just a quick example. You know, if you did a statement with gather plan statistics and you ask XPlan to show you that, you can see, you know, clearly estimated rows was 1, 2, 3, 4, and the actual number of rows was 32 million. So that's a problem. So some of this stuff, by the way, has been written about quite a bit. There's a guy named Wolfgang that wrote a paper called Tuning by Cardinality Feedback. I'd highly recommend looking into that. And there's a guy named Randolph Geist that actually wrote a little script that pulls some things together from a couple of other guys to easily show you, you know, where there are misestimates. So the little plan that I showed you is not too difficult to recognize. But if you've got one of these plans that's pages and pages long, sometimes it's difficult to see where that issue is. So these are just some tools that would allow you to go and see this sort of stuff easily displayed, even on 11 or 10 before you get to 12, and gives you some background for what they're trying to accomplish with adaptive optimization. All right, so evolution of the optimizer. Some people would say that it's gotten to the point where it's a little bit overdeveloped at this point. But just to give you sort of some history, you know, we've been on this path of trying to make the optimizer smarter and smarter for many years. And bind variable peaking was one of the first forays into that. Later we had dynamic sampling. In 11 we had this thing called adaptive cursor sharing. to fix the problems that bind variable peaking caused. So they just keep getting smarter and smarter about how they fix these things. Cardinality feedback showed up in 11 as well, which was a feature that would notice those misestimates and try to make adjustments on subsequent executions. You guys are probably aware of those things. And then they also have the tuning advisor that can recognize those as well. So the trend is definitely towards more dynamic plans, which is to say that just because you get a plan initially doesn't mean that you're going to stick with that plan. There's many mechanisms inside Oracle now that will change plans on subsequent executions. The biggest drawbacks as of 11G to the approaches that we had were, number one, that your statement had to run badly before it would notice that something was wrong. So many of you guys, I'm sure, have experienced that, where you get a very bad execution, and then one of these features like cardinality feedback kicks in, and the next execution is better. The other drawback with 11G was that these dynamic fixes, were not persisted anywhere. So cardinality feedback, for example, if it kicked in and got the plan right the second or third go-around, if your cursor got flushed out of the shared pool for any reason, it's going to have to relearn that information, again, which means that, every time it gets parsed, you got the potential to have a bad execution plan that's going to cause you problems. So that's the two major shortcomings we had in 11G. I did this presentation originally at Hot Sauce not a year ago, but say 6 or 8 months ago, and at that point it was still beta, so I had to put in the safe harbor, but it's not beta anymore, so now we're in 12C production release, so we can talk about all this stuff without having to worry about safe harbor stuff. Okay, here's sort of a overview of adaptive optimization and the various pieces of it. The two main pieces of adaptive query optimization are what we call adaptive plans, which is plans that get changed on the fly. And then we have another sort of sideline piece of it called adaptive statistics. So adaptive plans attempt to improve the initial execution. So an adaptive plan, we'll talk about it in a little more detail, but basically adaptive plans try on the fly, on the first execution, to make a change that's going to improve the performance, so that we don't have this, you got to have a bad execution before it notices. Adaptive statistics are still related to the way we did things in 11G, which is to say that I have to recognize something and I have to reparse and get another plan on a subsequent execution in order to get some improvement. So there's sort of two approaches to it: adaptive plans and adaptive statistics. On the adaptive statistics side, there's also a split between things that can be done at compile time and those things that are done at runtime. The compile time stuff is dynamic sampling, which you're probably aware of and familiar with already from previous releases. So the ability for the optimizer to go and actually look at the data distributions as opposed to just taking whatever the statistics say about the data. And then the runtime stuff is the cardinality feedback kind of stuff. So keeping up with statistics as a plan is executed and seeing whether the estimates that it had were accurate or not. So that's those two pieces. Mostly we're going to focus on this part during this presentation. The adaptive plans is probably the more interesting. We will touch on the other ones, but probably not spend as much time on them. They're towards the end of the presentation, and I suspect we'll probably run out of time before we can really dig into those in a lot of detail. And by the way, these slides will be available. I'm not sure if Redgate probably puts them on their website as well, but also they'll be available on my blog if the PDF is not available on the Redgate site. All right, before we go any further, a couple of new terms. So the words adaptive optimization to Oracle mean any dynamic change to a plan. So as I showed you in the previous slide, that includes dynamic on-the-fly changes and also statistical changes that affect subsequent plans. The term adaptive plans means a change from the default plan that Oracle would have used in 11G, sort of, on the first execution. So a plan that was modified in mid-execution during the first time it's run. Automatic reoptimization is subsequent executions. So you can think cardinality feedback. Statistics feedback is the new name for cardinality feedback. So you'll see in the documentation, you'll still see some cardinality feedback, but in general they're trying to change that term to say statistics feedback. Dynamic statistics is the new name for dynamic sampling. So again, you'll still see dynamic sampling some places, but in the documentation they're trying to change that to dynamic statistics. And there's a brand new thing that, unless you've been messing with 12C or reading up on it, you may not have heard of yet. It's a thing called a SQL plan directive. And what SQL plan directives are, at least in the first release of 12.101, is basically a persisted version of dynamic sampling. So the intention is to add some other sorts of directives, but right now it's a persisted form of dynamic sampling. Okay, so just to help you sort of keep the terms straight, statistics feedback, cardinality feedback, names are similar. Dynamic statistics, dynamic sampling. So those two things should help you sort of keep that straight in your brain. And SPDs is the same as PDSs, another little mnemonic. All right, so in the explain plan output via XPlan, down in the notes section, you'll see indications of if any of these sort of features have been used. So here's an example where you had multiple different things. There were SQL plan directives used. There were dynamic statistics. Note that they put dynamic statistics and dynamic sampling in. They also mentioned statistics feedback, which would have said cardinality feedback in previous releases. And it also tells you whether it's an adaptive plan or not. So all that stuff comes out when you do an XPlan for a statement. All right. So the first topic we're going to cover is the join methods part of adaptive plans. There's basically two main parts to adaptive plans. One is the join methods, so nested loops versus hash joins, and the other is a parallel distribution method that it can change on the fly. So let's talk about the join methods first. All right. First off, in case I haven't made it abundantly clear, the optimizer can change its mind in mid-execution on the first execution of a SQL statement. So that might be a little scary. Don't panic though. The sort of design goals of this feature are very sound, and it's visible what they've done. So it shouldn't be too scary if you think about it for a little while. Although I will tell you, the first beta event that we attended over 2 years now ago, I guess, one of the guys was sitting next to me, was another Oak Table guy, and when they told us about this feature, he looked over at me and said he thought it would be a consultant's dream to have the plans changing on the fly during the first execution. But again, I think it's all based on sound design goals, so I don't think it's as scary as we did when we first heard about it. So the join methods, how many join methods are there available to us in Oracle? Well, there's three. There's nested loops, there's hash joins, and then there's a sort merge, and then there's various flavors of those three things. For this first release of the 12C, we have two join methods that they can make a choice between for the adaptive execution plans. So basically it's limited to nested loops and hash joins. And should be pretty intuitive to you that if the optimizer thinks he's going to have a fairly small number of rows coming out of one side of a join, that doing a nested loop on the other side, might be a good option. And so, but occasionally when there's a misestimate and you end up having millions of rows, doing a nested loop join becomes very, very expensive and very slow. So as opposed to recognizing that after the very, very slow execution, they decided to do something where they could keep up with a threshold of rows that are coming back from the nested loop, and if it exceeds that threshold, then they can change their mind and go to a hash join. Interestingly enough, they have also the reverse capability of going from a hash join to a nested loop. But the nested loop to hash join is probably the simplest to understand. So we'll come back to that in a second, but before that, you know, the first thing that I wanted to think about when I first saw this feature was how do I turn it off? So you guys may be interested to know that there's several ways to do that. Optimizer adaptive features is a big knob that lets you turn off any of these adaptive features. Obviously, setting optimizer feature enabled back to a previous version would disable this capability as well. I wouldn't recommend this one. You know, I would prefer to turn it off with optimizer adaptive features if I was going to turn the whole thing off. There's a mode called adaptive reporting only that if you want to see what would be changed but don't actually allow it to make the changes, you can set this mode and be able to see what adaptive plans would be enabled but not actually implement them. And then there's some underscore parameters. Optimizer adaptive plans is false, so we could disable the adaptive plans but leave the adaptive statistics. Optimizer use feedback is the cardinality feedback feature, and that's the way to turn it off. And then we could also turn off dynamic sampling if we wanted to. Okay, that's it for the controls. Now let's go back and talk about the switching from one join method to another. So here's a little sort of diagram to sort of show you what happens. If we do a query and Oracle's default plan based on its statistics is to do a nested loop, what it's going to do is it's going to put a little statistics collector into the algorithm that says, let me keep up with the number of nested loop rows that I get on my table scan on the left-hand side of my join. And if I exceed some number, then I'll give up on that and I'll fail over to the hash join. So the way that this works is it actually builds two subplans or partial subplans, two alternatives, and builds those into the plan. And then it keeps up with the statistics, and then at some point it can trigger a failover to the other join method. If it makes the decision to do that, it disables the statistics collector piece of it at that point, so there's no point continuing to slow down the processing by collecting those additional statistics. And once that plan has been determined, it's going to remain for subsequent execution. So it's not, on the next execution, it's not going to go back and try to relook at multiple plans. It's just going to go with the plan that it's got. Okay. Finding plans that have been adapted is pretty easy. There's a new field in $SQL called is resolved adaptive plan, and if that's set to yes, then this is a plan that has been modified on the fly from what the optimizer thought it should be to start with. So it's pretty easy to do a select statement and see what all plans are out there that are adaptive. Okay. Just as a sideline, there's a field in $SQL plan called Other XML that is chock full of all kinds of information. Oracle seems to use it as a place to stuff things that they either haven't figured out what to do with in a normal data dictionary table, or just stuff that they want to keep up with for individual SQL statements. For example, all the hints the outline hints that are necessary to hopefully recreate that plan are stuffed in the Other XML field. But also the info that it's an adaptive plan, that's one of the places that it's stored, along with some other information. So, such as dynamic sampling, and SPD is the SQL plan directive. So if there's SQL plan directives, they're also stored in the Other XML field. Display map is an interesting one. That's how it keeps up with what steps in a plan were actually used. And when you do an X plan to display the plan, which I'll show you this in a minute here, that you can see the original plan that it would have used, you can see the final plan that it adapted to, and you can see a combination mode that shows the steps of both. So the display map tells X-Plan which steps are which in that scheme. You can also, if you do a little XML query or you look in a Wolfgang kind of a trace, you can also see this stuff in a little bit better format. So there's a picture of something of a trace file. Okay, so I told you you can display 3 different versions of the plans. You can display what the default plan would have been. You can display the final plan, and then you can display this mixed mode plan. The default is to show just the final plan. If you do X-Plan or X-Plan display, all you're going to see is the default. So if you want to see what that default plan was, you can turn off the feature. So you could set optimizer adaptive to false, do an X-Plan, and you're going to see the standard plan. You can see the final plan just by doing the standard display cursor. And you can see the mixed version by using X-Plan, DBMS X-Plan with the format syntax of adaptive plus report. So it would look like that. Select star from table, DBMS X-Plan, give it a SQL ID and a child number, and then give it the format of adaptive plus report. All right. That particular format is going to show you all the steps, even the ones that have been abandoned in the final plan. And the abandoned steps are going to be marked with a dash in front of them. Okay, plus report is important. Here's some output from a system to show you what a plan would look like. So if I wanted to see the default plan, I just set optimizer adaptive features to false, run my query, and then do an X-Plan display cursor. And that's what the plan would have been. That's not the one that actually ran. Right? If I want to see the final plan, all I have to do is just a normal display cursor right out of the shared pool. So, and it's going to show you the note down at the bottom that it was an adaptive plan. So that's the final plan. You don't have to do anything different or special to see the final plan adaptive statement. If you want to see this mixed mode version, you have to use the the adaptive plus report format, and it's going to tell you down in the note that the rows marked with an asterisk are inactive. And if you look over on the left-hand side of all the steps, you can see that there's a number of steps that are marked with an asterisk in front of them. So if we look back at the final plan, which is just this hash join with the 2-table full access, and then when we look at this plan, you'll see that all the nested loop and statistics collector steps are marked out. And so what we're left with is a hash join with the table access full and a table access full. So, if you want to really dig into a plan and see, what was there originally, what got eliminated or abandoned, and compare that, then this is the way to do that. Okay. The plus report does a little bit of extra. It also shows down at the bottom after your normal X-Plan, it's going to show you the final plan and the plan that would be executed if it was an adaptive plan. So you get a couple of different extra things at the bottom of the report. I'll just skip through that. All right, so that's pretty much it for the way the join methods are manipulated with adaptive plans. Just real briefly, I thought I'd mention that SPM interaction with those behaves pretty much as what you would expect. So if you're using baselines in 11G and you're wondering how that's going to work with these adaptive plans in 12C, it behaves pretty much like you would expect. final plan, final adaptive plan that it comes up with, that's the one that's going to be captured by the baseline. So once you've got a baseline, the plans are not going to be marked as adaptive anymore because it's not actually going to do that checking. It's just going to run the baseline plan. So pretty much I think it behaves the way you would expect it to. Unaccepted plans, if you're doing capture on baselines, plans that have been captured but haven't been accepted yet will be marked as adaptive so that you can see that. But once you've accepted the baseline on those, then the adaptive flag is going to go away. And one other just quick side note, baselines actually store plans now in 12C, not just the hints as they did in 11. So the big advantage of that is that we can do an X plan and see what the plan that the baseline was trying to reproduce actually was, even if it's not reproducible. So for example, if you had a statement that was using an index and for some reason that index got dropped, you could say, show me the plan, and it could actually reproduce the plan in an X plan output format, even though that index doesn't exist anymore. And in 11G, we can't do that, which is a little bit frustrating. So anyway, just another advance in 12C. All right, so here's just an example. Created a baseline on this particular statement, same one that we looked at earlier. And so you can see that it created a baseline on the hash join plan. It's no longer marked as adaptive. It just says that it used the baseline to recreate the plan. All right, so that's it for join methods on the adaptive plans. The next topic is parallel distribution methods. So another thing that they can adapt on the fly in 12C is the distribution method for parallel queries. So they actually have a new distribution method called hybrid hash, and it's pretty much a hash distribution method. So it's going to try to send records to slaves based on a hash algorithm, but there is a statistics collector inserted in front of the parallel process to capture how many rows are going to each one of the slaves. So if it notices that there's not an even distribution of rows going to the slaves, or not enough buckets going to the slaves, then it can fall back to a broadcast distribution method. And it is enabled by default. So just to give you a sort of a diagram of what I'm talking about, if you've got a parallel process and you've got two sets of slaves, the hash sort of algorithm would look something like this, right? Where as records are coming into P1, based on a hash algorithm, I'm going to distribute the rows to the slaves with that hash algorithm, right? And that's going to happen for each one of the input side of the parallel slaves. Now, what we hope is that the distribution of data is even. So, you know, if that blue square in each one of those boxes is represents the amount of data that goes to each slave, then that's what we'd hope to see, is sort of an even distribution of them, so each slave gets about the same amount of work. If, on the other hand, the distribution doesn't look like that, and we have some sort of skew and an uneven distribution, and say all the data ends up going to one slave, then this sort of a distribution method doesn't make much sense, and we end up having one slave that's trying to do all the work and the other ones are sitting idle or almost idle. So in that case, the adaptive optimization can say, well, you know, this was a bad idea. Let's drop back and use the broadcast method, right, to send the records, evenly distribute the records across the slaves, or send the records to all slaves and let all the slaves work on all the records as opposed to trying to hash them. So anyway, the result is that it can change the distribution method from hash to broadcast. And the default for when it makes that decision is 2 times the degree of parallelism. So if I've got a really low number of values that I'm going to distribute, then it's going to automatically fall back to the broadcast method. All right, so that's it on the parallel distribution methods. Let's fail over to the statistics, adaptive statistics side, and let's talk first about dynamic sampling, which is called dynamic statistics now. So dynamic statistics, you're probably familiar with these already in 11G. The idea in 11G was to make up for missing statistics primarily. Could be used for table scans, index access. In 11G, in 12 we can also use it for joins. And the optimizer computes a time budget for collecting these things at runtime. So statistics are stored in memory and can be shared across queries. So this is a difference for 12C as well. There is a Randolph Geist, I mentioned him earlier. He has done a number of blog posts on dynamic sampling. So if you're interested in really understanding how the dynamic sampling algorithms work, I would highly recommend looking at some of his blog posts. I've got a post on my blog that has a list of a number of blog posts that he's done because I couldn't find a good list anywhere. He didn't have a list on his blog, and nor could I find one anywhere else. So anyway, I built my own list. So if you want to look for a list of his presentations on that, then check out my blog for that. One of the new things about 12C is that dynamic sampling now goes to 11. So you've got 11 parameters that go to 11. This one has a new level, and basically it's a totally automatic, I can do dynamic sampling anytime I want to setting for Oracle. So the default is still 2, so they haven't actually changed the default to 11, but they do allow you to set that, and basically it becomes a totally automatic setting where the optimizer can choose to do dynamic sampling on any query it wants to. So that's kind of cool. Okay, so moving on to adaptive statistics at runtime, cardinality feedback basically. During the execution, we mentioned earlier that the cardinality feedback in 11G, you know, was a subsequent execution kind of a thing. It didn't help you during the first execution, but would calculate numbers and then try to apply fixes, you know, in the subsequent executions. 12C still follows that same basic methodology. However, you know, the shortcoming with 11G was no persistence, and so the thing about 12C is that we do have the ability to persist that information, and so just to back up on 11G, the statements were monitored once to show if significant differences existed, and they were limited to table cardinalities and group by estimates, but they couldn't deal with joins. So, and it was only stored with the cursor. So if the statement got flushed for any reason, you're going to lose the cardinality feedback stuff, and thus have to go through the painful process of rediscovering it. So in 12, join statistics are also monitored, and the data is persisted, right? So we don't have to rediscover it every single time. So the way they do that is with SQL plan directives, which brings us to talking about SQL plan directives. Here's just a little note from the 12C release 1 packages reference, but basically it's saying that these SQL plan directives are a way of storing information about statistical information so that it can be reused between executions and actually between statements. So it doesn't store the information on a single SQL ID basis, but basically on the objects, the underlying objects, the tables and columns in the queries themselves, so that they can be reused by multiple statements. So there's a couple of ways to look at what directives are getting created. There's a view called SQL plan directives, which is basically tells you what the name of it is, and there's a notes section that shows you a little bit about what they're actually storing for that particular directive, and there's a couple of fields, type and state, which we'll talk about here in just a second, that give you some information about what's going on with it. The second view is DBA SQL Plan Directive Objects. So that's individual directives that are related to either a column or a table. And I'll show you some output from what those things look like. So here's the SQL Plan directives that we got created on the order items table. We had a directive on the table itself, and then we had a directive on the unit price and the quantity. If we looked at the directive on the table and looked at the notes section, you can see down here that we've got information about, you know, what sort of an operation we're keeping statistics about. Right, so we have an equality predicates, we had an index access by join predicate, filtering on join object. So the notes section gives you some information about what sort of information it's keeping. When we look at the types and the state and the reason, the only type that is valid at this point is the dynamic sampling type. And we have a couple of different states. If we look here, I did a select from a 12C system that we had run some workload on, and dynamic sampling was the only type that showed up. There's a couple of different reasons that showed up in my system, and then we had several different states. So we have a has stats, we have a new, we have a permanent, and we have a missing stats. And when I did a count on those things, most of them were in the has stats category or state. And so let me talk about that just a minute. The meaning of those states is the first time I go through a statement and I find that I need a SQL Plan directive, those things are going to get set to new. If I go and see one that says missing stats, then that's telling me that I need to have extended stats created for a column group typically. And those things will be gathered automatically by the next statistics gathering event that happens, you know, by default in the evening. Has stats says that I did gather the extended stats that the SQL Plan directives instructed me to gather. This is sort of an intermediate state that doesn't necessarily mean all of the SPDs are going to be eliminated. And then there's a permanent setting. Once the extended stats have been gathered, you may end up with an SPD that still sticks around because of some things that the extended stats can't handle, like a not equal predicate. So that's the 4 states that you may see these SQL Plan directives in the database. And according to the development guys, dynamic sampling is the only reason for those things at this point, but at some point in the future they expect to add additional reasons for that. There is a new package called DBMS SPD that you can use to manipulate these things, but there's not really much to manage. You can flush them. They're flushed every 15 minutes by default from memory, or persisted every 15 minutes. You can also drop specific directives if you're doing testing and you want to eliminate the SPDs so that you can retest from start or from scratch. You can drop them as well. All right, so that's pretty much my presentation. Quick wrap up. You know, there's 12C's got, you know, a lot more automagical stuff than we had in 11G. We do have the ability to see what's going on with it, though. Name changes can be a bit confusing when you're looking through the documentation, especially the first release of the documentation where they're just kind of getting settled down on the names. They are statistics happy in the naming for sure. You know, you'll see statistics all over the place. Dynamic sampling, now they're calling it dynamic statistics, cardinality feedback, statistics feedback. I want to reiterate that I think the ideas are very sound for this adaptive optimization. Learning from execution statistics is a sound practice that, you know, guys that are doing tuning have been doing for a long time already. And so implementing it into the code is, I think, a good move in the right direction. Trying to eliminate that, have to run bad, at least once before you get it to kick in, I think is the right thing to do. And certainly adding persistence is a good thing to do. And this stuff is default, right? So, so two comments about that. Number one, Oracle doesn't make, the development guys don't make features the default unless they're pretty confident that it's going to work well and that it's not going to be buggy, right? So they made it the default, so you know that they're pretty confident with it. And the second thing is you're going to see it because it's the default, and people tend to install databases with the default parameters. You're going to start seeing this stuff showing up as you're moving to 12c. So I've got about 10 minutes left, I think. So at this point, I thought I would give you just a real quick log on to a system and show you what it looks like. Let's see if I've got one. Here's one already. So here's a window into a 12c system on an Exadata, actually. And one of the first things I wanted to do was to look at what all statements were actually using adaptive optimization. So I wrote a little query to, show me all the statements that had that flag set. And so as you can see, just on this little test system, which really doesn't have any real workload running on it, we've got over 1,000 statements that are flagged as having adaptive plans. So that's quite a large number and should give you an idea of how prevalent this thing is going to be. So if I wanted to do this again and look at for a specific set of statements, let me look for something that has order in it. No. Look for tables that have the product table in it. So here's one that we ran that has a dynamic plan or an adaptive plan. If I just do the normal X-plan sort of output for this thing, I'm going to see it's an adaptive plan. This is the same one that I showed you in the basically in the presentation. If I do if I give it that adaptive sort of format string, I can see the steps that have been eliminated in my statement, right? And if I look at other XML for this guy, oops. I'm going to see all that stuff that I showed you with the adaptive plan indication and all the other hints. And here's all the row stuff, the row display row map stuff. So this is all the information it uses to do the, the dashes in front of the steps and that sort of thing. So I think that's all I wanted to show you for right now. We could look at the plan directives and stuff, but in order to leave a few minutes for questions, I think I'll go ahead and cut it off here and let James go ahead and open it up for questions.
Hi, Kerry. Thank you. We do have quite a few questions in already. So please just give me a couple of minutes just to quickly, or a couple of seconds rather, just quickly scan through those, and then we'll go through them. If you've got some questions and you haven't already put them into the question panel, please do so now. Obviously, this is a great opportunity to put your questions to Kerry on this topic. Obviously, as Kerry has mentioned, and as I mentioned at the beginning, this session is being recorded. I will send you an email when the recording is up online. Similarly, the slides will also be available on the Redgate website and also on Kerry's blog as well.
Okay, so Would you like me to just start reading down through some of the questions and answering them?
So if I ask them to you, I think that will help everybody through them. But please do obviously interrupt me if some of the questions you've already kind of gone over maybe earlier on in the presentation.
Okay.
Okay, so the first question here, if we had a SQL plan baseline set for a particular SQL in version 11G and we were to upgrade to 12C, would the SQL baseline be used or this adaptive plan would be used instead?
Yeah, so if you've got a baseline already enabled for us, a statement, it's going to use the baseline and the adaptive would not be allowed to kick in if it was going to do something different. So the way the baselines work is it will apply the hints to try to recreate that plan. So unless the plan was not reproducible, it would use the baseline plan.
Fantastic. Thanks, Kerry. I do apologise for the slight echo there. Okay, next question here. Does adaptive optimization help Oracle optimize somewhat complex nested views? I know nested views are not recommended, but we sometimes have to live with what we have inherited.
I haven't tested with nested views, but basically all the adaptive plans can do is change from a nested loop join to a hash join or vice versa. So one of the things I probably should have shown you was an example of a hash join going back to a nested loop join. That's a little counterintuitive, but I'm not sure that it's going to do much for you on the nested views, other than if it notices that it's got a nested loop that it thinks is going to have a low number of rows coming into it, and it gets a large number of rows, then I would expect it to go ahead and make that change to hash join.
Okay, thanks, Kerry. So the next question: what happens with the rows that were read up top inflection point? Does Oracle start reading from the scratch again?
No, it buffers those rows.
We've got a question here regarding turning off the adaptive optimization, particularly adaptive joins. Will there also be a hint to disable it for particular SQL?
Yes. If you'll shoot me an email or leave me a comment on my blog, I'll go and research that. I'm pretty sure there's a hint, but it's not right at the top of my thoughts at the moment. So let me go back and verify that, but I'm pretty sure there's a hint to disable it as well.
Great, thanks. I say the next question. So this one's a little bit difficult, so just bear with me. Okay, I think I'll just answer the second part of this. So can you pick and choose SQLs not to run the collector on, if that makes sense? So this is to do with statistics.
Not to run the collector with? I'm not sure I'm following the question. No. Are they asking if you can control individual SQL statements to allow the adaptive to kick in or not?
Yeah, I think this one needs probably a little bit more explanation.
Well, certainly you can do it with an alter session in front of a SQL statement. I think you can do it with a hint, but I have to go back and refresh my memory on the hint.
Okay. So next question here. In the pro C sequence, prepare, open, fetch, at what point might Oracle switch plans? If during fetch, how does Oracle return the next row stroke array?
That's a great question. I haven't tested that. Haven't written Pro C in a long time, but that's another good question that I would like to test. So if you want to shoot me an email, I can try it.
The next question, does AWR or a SQL trace output show the updated adaptive plans?
Yeah, so AWR is going to show you the final plan. There's not actually, AWR doesn't really show you plans, but the only thing that would be reported by the default methods are the final plans. So just like baselines work with final plans, so with the reporting.
Okay, thank you. So next question here, does adaptive distribution for parallel processing work as expected on a virtual server where resources can be spread over several other servers?
I have no idea.
So as Kerry's just mentioned, any questions we can't or we don't have time to get to or we don't have an answer for now, please do put them onto Kerry's blog. Hopefully we can answer them there. Question here, can we force dynamic sampling for a statement regardless of what Oracle thinks it should do?
Yes, there's a hint to do dynamic sampling, and also you can set it to whatever level you want it to. So unless you manually set it to 11, there's fairly well documented set of things that it will kick in on depending on what level you set it. So if you set it to 0, you're not going to get any dynamic sampling. If you set it to 1, 2, 3, 4, you get specific things that it'll kick in on. So you can control that.
I think this question leads on. So for adaptive plans, usually queries are more complex with multiple combinations of hash joins and nested loops, but adaptive plans only switch to one subplan. Is that correct? And how does it account for all the various combinations?
Yeah, so it creates subplans for join conditions. So if you've got multiple join conditions, I don't know if there's a limit on the number of join conditions that it would consider, but that would be an interesting thing to test as well. But yeah, it should be able to do, within reason, all the joins should be able to consider both options.
And does adaptive optimization reduce the need for using hints?
Potentially. I don't know that I would assume that. The reason we use hints in the first place is because the optimizer's not doing what you want it to do. Certainly, it should help us with situations where we have something that has to run badly before one of the features can kick in, adaptive cursor sharing or cardinality feedback or something like that. And so in those cases, sometimes we end up hinting things because we want it to always run a certain way. So in those cases, it's quite possible. But in general, we only revert to hints when we can't get something to behave the way we want it to. And while every iteration of the optimizer seems to get better, there always seem to be things that we still need to take control
of. Next question here, can hash joins be changed to nested loops in the first execution? What threshold is there for such a change?
Yeah, I don't know what the threshold is, and I'm having a hard time getting my mind around why you would ever go from a hash join back to a nested loop, but it certainly can be done. I was going to show an example of that, but I think I will not try to do that. But yeah, you certainly can go from hash join back to nested loop, and I don't know what the threshold is.
Thanks. So question here, is there a way adaptive optimization can be disabled for PDB and enabled for others? I'm guessing this for a private database, correct?
What is PDE?
PDB.
Oh, for pluggable databases?
Okay.
Yeah, so I don't know if there's any sort of special restrictions with PDBs for adaptive optimization. I don't believe there are. I believe it's just a standard feature that should work in a PDB just as well as it would anywhere else, so in a non-container database. But again, if that's, shoot me an email with more specifics on what you're driving at there, and I'll be happy to look into it.
I'm guessing the answer to this is yes, so it might be better to ask the question of what effect on CPU utilization or how does adaptive optimization affect CPU utilization?
I'm not sure I'm following that question exactly, but if the concern is this does adaptive put additional load on the CPU per execution, the answer is certainly you've got a little bit of overhead from the statistics collector, but it's very, very minor. And again, it is only in play until it makes the decision whether to switch or not. And so the amount of overhead is not really measurable. The little bit of testing that I've done on the overhead, was not something that you could, was even noticeable. So.
Great. And what data volumes does adaptive optimization become likely to be helpful? What volumes does it really help out?
Well, if you do any testing with a nested loop join on, where you have a whole lot of records coming in on the front side of it, the execution times can go through the roof. So that's the classic, when do I use an index in a nested loop versus when do I do a full table scan kind of an approach. So anything where, where the execution time is noticeable, you should see the, big difference from it, right? So the answer is it just depends on the, the data volume that it takes to make a difference in your execution time. It's just the classic, when does it make sense to fail over to an index nested loop join versus a hash join?
Great, thanks, Kerry. And the final question, thank you everybody for putting their questions in. This is a general question for you, Kerry, just in terms of, are you speaking at UK OUG and what sort of upcoming conferences will you be at?
I'm not going to be at UK OUG. I will be at Hot Sauce in February or March. I'll be in Denver at the Rocky Mountain Oracle User Group. And I think that's all I've got on the calendar at the moment.
Great, thank you. So once again, thank you for everybody for joining us today. I hope you've enjoyed the session as much as I have. I'm sure you have as well, Kerry.
Yes, I have.
Fantastic. And I'm sorry if we weren't able to answer any questions or kind of get to your question. Hopefully, though, that the questions that we did answer did also help you out. I will send round an email in the next couple of days. Those of you who come to these sessions regularly will know that I do try and get the recordings up quite quickly. As soon as I do, I'll send a link round where you can download, where you can watch the video. It'll also be up on YouTube. I'll also I'll include a link to Kerry's blog as well, which is obviously up on the screen. But please do check it out and put any further questions there. So I'd just like to finish off by saying thank you once again, Kerry, for taking today's session. And as always, thank you, everybody, for joining us today.
Thanks.
Thank you, and good day or good evening, depending on where you are in the world. Thanks again.